Okay, here we go. Let's take a look at Geometry 1.5 practice problems. The first 8 here, you should be able to use your notes and figure these ones out. Just remember, complementary means the angles add up to 90. Supplementary pair or a linear pair add up to 180. And adjacent is just next to. There's nothing significant about them. They don't add up to anything. But they're just next to each other. That's adjacent. And let's see, vertical angles. So number 3 would be a good example of that. It is made up of two opposite rays. Ray going this way, ray going that way. These would be vertical angles and making these two angles congruent. Okay, move on to numbers 9 through 16. Looks like we're just finding the measure of the angle. So here, let me zoom in a little bit more. Number 9, we see that this box right here would indicate that that is a 90-degree angle. So that just means that this angle B and this angle here have to add up to equal 180. So this is just going to be B plus 49 is equal to 90. Just subtract 49 on both sides, and you're left with B is equal to 41. And there you go. All right, the next one here, number 10, we have B and 62. We should know that this is a straight line, right? And a straight line is half of a circle. A circle is 360 degrees, so half of a circle is 180 degrees. And so we can see that angle B plus angle, the 62 degree angle, have to add up to 180. So we're just going to set up an equation like that. Solve it the same way you did number 9. All right, some of these are pretty easy. You don't really have to do any math. If you recognize that these two angles here are vertical angles, well, we know that vertical angles are congruent, so B equals 53. All right, number 12 looks a lot like number 9. 13 looks similar to 10. 14, we'll try one of these. Few ways you can do this. I think the easiest way to do this would be to say we know that a full circle all the way around here would be 360 degrees, right? So we just want this little piece here. So if we subtract this 297 and we're left with 63, now we know that this angle here, right, this whole thing is 63 degrees. So now we can say B plus 29 is equal to 63 and go ahead and solve that equation. All right, I might have to zoom out. Hopefully we can see this on my screen here. Maybe I'll just go through all these. 17 through 26, we're going to look at this diagram and see if we can make the following conclusions. Okay, so number 17, angle J, okay, right here, and angle D are congruent. Is that true? Yes, it is, because of these markings right there. Those are showing that the angles are congruent. So yes, that is true. All right, how about 18, angle JAC? So we have to identify that JAC. So they're talking about this angle here and angle DAC, that angle. Are those true, or are those angles congruent? It certainly looks like they might be, but it is not indicated here. We don't have any, arcs like that indicating that they are congruent. So no, we cannot draw that conclusion. All right, number 19, the measure of JCA, and measure of DCA. So again, we're talking about these angles here that certainly look like right angles. However, we don't have that box here, so no, we cannot draw that conclusion. Remember, we cannot assume right angles, so no. Number 20, the measure of JCA. Let's look at that JCA. Okay, that's this one again. And ACD, ACD. Do those add up to 180? This we can assume because we see that this is a straight line, so we know that these angles have to add up to 180, right? We can't really assume that they're both 90. You know, this might be slightly off, and one might be 91, and one's 89. We can't say that they're both. We know that the angle of either one of them, but we do know that they have to add up to 180. So yes, this one, we can make that conclusion. All right, number 21, angle of JCA, JCA again. Is it right? Again, we cannot assume right angles, so no. All right, 22, segment AJ. A to J, that's this segment here, and AD, that's right there. Can we assume that? Yes, we can because of these markings right there. Yes, that's true. Okay, how about number 23? The measure of JAE, JAE. Talking about this angle here and this angle here. Boom. Oh wait, not that angle. Sorry. EAF. Sorry. EAF would be this angle. So these two angles, would these be supplementary? Let me erase that. Sorry. JAE and EAF, are these supplementary? Or in other words, do they add up to 180? I'm going to erase. We see that this is a straight line, right? We know that straight lines add up to 180. So yes, we can make the assumption that this angle here and this angle here would add up to 180. So yes, this is true. All right. Oops, didn't mean to erase that part. How about number 24, EAF? EAF, that's this guy here, and JAD, JAD. So they're saying this angle and this angle are vertical angles, and yes, we can assume vertical angles. So yes, we don't know the angle measures, but we know that they are the same. So we can make assumptions on vertical angles. Number 25, ray AC, that's this guy right here. Ray AC is the angle bisector of JAD. JAD is here. So does this ray cut this big angle right here? Certainly looks like it, but it's not indicated on the diagram, so no, we cannot make that conclusion. And C is the midpoint. Point C is the midpoint of this segment. Again, it certainly looks like it's true. You could get your ruler out and show it, but it doesn't indicate it on the picture, so we cannot assume it. That is a no. All right, moving on. Oops, moving on. These are very similar to, these ones are kind of hard to see. These are pretty similar to 9 through whatever on the front page. We're just solving for x. So 27, we know that the whole thing, we have a straight line, right? So we know that this big angle across here would have to add up to 180. So all we have to do is say, well, 5x plus 25 is equal to 180, and then solve for x, right? Subtract 25 on both sides, get 155. Cancels out. We're left with 5x is equal to 155. Divide by 5 on both sides, and we get x is equal to 31. Okay. Number 28. This is going to be the same thing, just we're looking at a right angle. So this is going to add up to 90 degrees. So we're just going to do 2x plus 11 plus 53 is equal to 90. You can go ahead and solve that guy. 29, we're dealing, ooh, this one's real hard to see. We've got, I think this is 3x plus 2. This is 62. We should recognize that these are vertical angles, and we know that vertical angles are congruent. So all we have to do here is go 3x plus 2 is equal to 62, and then we can solve for x. Okay. These all look pretty similar to ones I've already done before. 30. I'll solve this one just a little bit differently than I did the other one. We could say that all the way around is 360. So we could say, well, all these angles, if we add up the angles, right, the big angle, 296, plus 29, this angle, plus this angle, x minus 24, could set it up like this, combine these like terms, and then solve for x. Either way is fine, or the other way, so that's, you guys can solve that equation. Or the other way would be to just look at this little piece and just do 360 minus this big part here, 296. You're left with 64, and you could say these two angles here, 29 plus x minus 24 is equal to 64. You could try them both. You'll see that you'll get the same answer for x. Okay. Again, 31, very similar to 28. We're just going to add up the two, set them equal to 90. 33, pretty similar to 29. So I think you guys should be pretty set to solve these ones. Look at these algebra skills review. Looks like these are just solving equations. The first couple, graphing these lines out. We haven't really gotten to, oh yeah, we have. Let's go ahead and plot this. We've got the slope is here, and the y-intercept is right there. So we start at the y-intercept, 1, 2, and we just go up 1, 2, 3, over 4, 1, 2, 3, 4, or we could always go down 1, 2, 3, 4, 1, 2, 3, 4, and so there's your, oops, that's not way off. There's your line there. Y is equal to 2. This is just going to look like this. Y is always equal to 2. So that's going to be on the y axis at positive 2. You could put several options out here. You're going to get a horizontal line for that. Distribution, just gone through that a little bit. 2x times 5x, just treat the numbers as normal. 2 times 5 is 10. X times x is x squared. And the second distribution, 2x times negative 3 is going to be negative 6x. And here's kind of the opposite of distributing, undistributing. We can see what we can take out. We know we can pull an x out from each one of them. And what can we pull out in terms of numbers? These seem to both be divisible by 3. So I'm going to pull out 3x. Divide 21 by 3, we get 7x plus 11. All right. Hopefully this video was helpful. You should be able to answer all the ones that I didn't. If you still need help, come see me on a Google Meet. All right, good luck.